All right. So we're going to generate the correlation matrix. So look at your data set. Look at the top. You see the data tab. Click on the data tab, and on the far right, once again, select data analysis. We are about to generate correlation matrix, and I'm walking you through that. So click on the data analysis. You know, previously you chose descriptive statistics. Now you are going to choose correlation. 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 Do you all have correlation? You see correlation in the list?
Yes, Prof.
Double click it, a pop-up will show. Double click it, a pop-up will show. In that pop-up, you see input range once again. And like before, you are going to select all of the information in the input range, starting from Q, highlight and drag it all the way to RM, drag it all the way down to the last variable. Have you done that? When you are done, take labels in first row. You see, when the thing comes, I need to drag it up. Take labels in first row. And then take output range. Once you've taken the output range, you see the white space to the right of the output range. Click inside that white space. And now that is telling you that indicate where you want the results to be. I want my results to be directly below the descriptive statistic we found some few minutes ago. So just click the cell J17. I just clicked it here, J17, so that it will appear in the output range. Once you are done, click OK. And boom, you get a correlation matrix. Once you get a correlation matrix, it is highlighted gray. Don't click anywhere. Go to the home tab. See, this is in decimals, too many decimals. So I want to convert it to 2 decimals. So go to the home tab. At the home tab, you come to general again in the middle, general. Click on the little arrow near general and select number. Everything will be converted to 2 decimals. Click the little arrow close to general and then choose number. Everything will be in that. So on the basis of this, you are able to see, this is called a correlation matrix. This is known as a correlation matrix. So Excel can do correlation matrix for you. You remember we said some few minutes ago that the correlation is between -1 and +1. There you go. So you can see that in your correlation matrix, the numbers are between -1 and +1. Now we are going to make sense of this correlation matrix. But before we start making sense of them, I want those of you who have been able to do it to type Y, the letter Y, or yes. I want to be sure how many of you have been able to do the generated correlation matrix. How many of you have done that? 11, 12 people out of 50 something, only 17 people have done it. It means that some are watching us from day one. That's what it means, some are watching. Remember the question at hand, okay? So, correlation deals with association. And there are variables you see here. There are variables. The variables are Q, P, C, M, LU, OT, OTR, RC, RM. Those last ones are dummy variables. We know this. Now you can see that the correlation shows the relationship between a value and a value. So you are going to raise your hand and tell me when I mention something. Who can tell me the correlation coefficient between M and Q? Between M and Q. Justice.
Doc, 0.61.
Okay, thank you. Who can tell me the correlation coefficient between LU and RC? Between LU and RC. Between LU and RC. Who can tell me that? Osman. Osman. Yes, Samuel Asiama.
Dog, please, Osman is back.
0.65, dog.
My mic is off, dog.
All right. Who can tell me the correlation coefficient between RC and RM? RC and R. You see, your hand is up, so I would assume that you know why your hand is even up in the first place. RC and RM. Reg Gorbett. Reg Gorbett. Sumani.
FC and RM.
Okay, it's negative 0.53.
All right, negative 0.53. Finally, tell me the correlation coefficient between C and RC. Between C and RC. Lower your hand if you don't know. Della.
0.38, sir.
0.38, that is correct. So I'm just using this as a way to warm you. Now I'm going to ask you the next 10 questions under correlation. You got to know them. You got to know them. So let's go to the first question under correlation you must know. First question. Okay, and you want to note it down. I want you to tell me 3 pairs of variables that are perfectly correlated. 3 pairs of variables that are perfectly correlated. Now, the way you answer them is this. When I ask you, the way you answer them is that you say A and B. Then you tell me the correlation coefficient, maybe 0.88. Or you say C and W. And you tell me the correlation coefficient, negative 0.43. So that is how I want you to be answering them. So who can tell me 3 pairs, but who can give me the first pair or first 2 pairs? Because he said 3 pairs. The first 2 pairs of variables that are perfectly correlated. If you don't know, lower your hand. Okay, lower your hand before I call you and you said you didn't raise your hand. All right, Osman. Osman, Fa. All right, Justice.
Doc, please, Q and Q. And the correlation is 1.00. P and P correlation is 1.00.
Perfect.
And then M and M correlation is 1.00.
Fantastic. Very good. Very good. So guys, all those on this column, on the diagonal, they are the ones that are exhibiting the correlation, perfect correlation. Perfect here means that the relationship between them is defined by a correlation coefficient of 1. Perfect correlation. That's it. This is what is known as perfect correlation. All right. Now, so I said 3 pairs, so that's why he gave me 3 pairs. Okay. If I had not said 3 pairs, okay, whatever pair I say, that's what you do. Let me go to my next question. So now you know what perfect correlation is. Let's go to the next one. I want you to tell me 2 pairs of variables. 2 pairs. So first you give me 1 pair, and then you give me another pair. 2 pairs of variables that are mostly strongly correlated with the response variable. 2 pairs of variables that are most strongly correlated with the response variable. By the way, the response variable is always the first variable, is a dependent variable. The response variable is always the first variable, and it is a dependent variable. So let me take you back. Looking at the correlation, I want you to tell me two pairs of variables most strongly correlated with the response variable. That is with the Q variable. Zaid.
So the two pairs are highly correlated with the response variable. The first is P and Q, which is negative 0.87, followed by OT, R, and Q, negative 0.78.
Okay. So he said that the first one is P and Q, negative 0.78, because he's looking at this column. The response variable is this column. So he's picking the highest, highly correlated values. The sign doesn't matter. The sign doesn't matter. And that is why he's able to pick them nicely like that. Okay, who's not clear? Okay, so if I ask you, tell me two pairs of variables that are least correlated with the response variable, what would that be? Two pairs that are least correlated with the response variable. What would you say? Osman.
Prof, please, that would be RC and OT. That's 0.05. So,
that's wrong. Two pairs of variables that are least correlated. Don't worry. I just don't want you to come back. Just listen to others, okay, so that you learn. It's not the answer that matters. It's your capacity to get the answer. Two pairs of variables that are least correlated with the response variable. Della.
Q and OT, which is negative 0.11.
Who is mentioning the things and his microphone is on? Okay, your microphone is supposed to be off.
OT and M, that's the first one.
That's wrong.
And then RC.
That's wrong. That's wrong. Two pairs of variables that are strongly correlated with the response variable. Response, oh, people are just struggling all of a sudden. I have some more. Moru Ahasan. Okay, I don't go. I don't
yes,
go.
You said, yes, sir. You said those who are least correlated. So talking about the least correlation, I'm talking about those that have the smallest correlation number. And that would be OT, that's M and OT, which is zero, minus 0.
No, that's wrong. Remember, that's wrong. Yeah, I said those that are least correlated with the response variable. Hey, somebody answered highly correlated with the response variable. I'm not asking you just the least correlated with the response variable. And you're collapsing. Sumani. Sumani, unmute yourself.
Dog, I see OT and Q.
OT and Q. That is the first one. Okay.
And then RC and OT.
RC and OT. That is not the next one in order. That is not correct in the order frame. Hey, what has happened to PhD students? Prince Amu, tell them.
So we have Q and M 0.61.
Okay, Q and M 0.61. That is the next list in that is correlated with the response variable. Remember, the response variable is Q. This is the response variable, the Q. So we are looking for the two least numbers. The first one is negative 0.00, followed by 0.61. That is what we mean by response variable is the first column variable. So take note of this, learn these things. Let me go to the next one. Okay. Let me go to the next one. You have to know these things, so you have to know them. You have to know them like Kakai. I don't lie to you. You have to know them so well. Now, next one. Okay. I want you to tell me 3 pairs of variables that are mostly multicollinear. 3 pairs of variables that are mostly multicollinear. Multicollinear variables are independent variables. Independent variables. Okay. Remember, the dependent variable was Q. We said that before. Q here is a dependent variable. Now, the independent variables are all other variables. I want you to tell me 3 pairs of variables that are multicollinear. Multicollinear, okay, are 2 highly correlated independent variables. So who can tell me the 3 pairs? When you tell me, I'll highlight it. When you tell me, I'll highlight it. If you are not sure, lower your hand and listen to the others. If you are not sure, lower your hand and listen to the others. If you are not sure, lower your hand and listen to the others. If you are not sure, lower your hand. Richard.
Hello, Doc. So
Yes.
it is, the first one is P and P, which has a correlation of 1.00.
That's
the second
wrong.
one is...
That's wrong. Let's go to the next person and listen to the others. 3 pairs of variables that are highly multicollinear. Multicollinear. Put this down. Put this down. I'm giving you the definition of multicollinearity. Multicollinearity exists when 2 independent variables are so highly correlated that it becomes difficult. When 2 independent variables are so highly correlated that it becomes difficult to disentangle the partial effect. It becomes difficult to disentangle the partial effect of one from the other on the dependent variable. It becomes difficult to disentangle the partial effect of one from the other on the dependent variable. So multicollinearity first must be independent variables. It must be the relationship between only independent variables. Independent variables, that's the first thing. So those that are, and then I didn't say they are perfectly correlated. Perfectly correlated means that they are having a correlation of 1. No, multicollinear are highly correlated. That's what we said, not perfect. There's a difference between perfect correlation and high correlation. So first, they must be independent variables. So anything on the dependent variable column is not part. Second, they must be closest. The closest, that in this case, I'm asking for the 3 most closest one to 1. So who can tell me the 3 pairs? Let me go to Kofi Odroboat.
Okay. The first one is OTR.
First one is what?
P and OTR.
Always mention the number.
Okay, P and OTR 0.76.
0.76. That's your first one.
The next one is P and C 0.74.
-0. You didn't add the negative. Should I give you wrong?
No, please, negative 0.74. And the last one is LU and OTR, negative 0.65.
No, the last one is wrong.
I'm wrong. Please, can I attempt to actually listen to the others?
Oh, finish it.
Okay. There's C and M, 0.71.
No, that's wrong. Your eye must comb the thing always very well. All right, let's listen to somebody now. Zelda, tell us.
M and RM, negative
M,
0.73.
That's it. Okay. So those are the most highly. So even though negative, 0.87 is high, it is on the dependent variable column. And multi-collinear variables must be independent variables. So you cannot add a dependent variable to the list. But you have to mention them in order of appearance. So 0.76 comes first, negative 0.074 comes second, negative 0.73 comes third. If you disorganize the ordering, that is wrong. The ordering is very important. Now, the last one for today. Tell me three pairs of variables that are highly correlated. I didn't say three pairs of variables that are highly multicollinear. Rather, three pairs of variables that are highly correlated. Your understanding is important in this question. Okay. Your understanding is critical. Yeah. Clement.
Hello, Doc.
Yes.
Yeah, I wanted to answer the.
Don't worry. We'll go to the next person.
But they have,
don't worry.
They have done with that one.
Let me go to the next person. Zaid.
For the pairs that are highly correlated, the first is P and Q, negative 0.87.
P and Q, negative 0.87, correct.
Followed by OTR and Q, negative 0.78.
Yes.
Negative 0.78. And the last one is Q and R.
Q and R.
Negative 0.76.
Good. And the last one can also be what?
It can also be another 76 here. P and OTR.
P and OTR. Very good. So that is how you identify. So the difference between highly correlated is that the highly correlated doesn't care whether it's dependent or independent variables. But the highly multicollinear, it cares that it is independent variable. It cares. Okay. So highly correlated is different from highly multicollinear. Now, ladies and gentlemen, what we've just done now is that we've been able to learn how to establish correlation. We have not been able to show whether the correlation is significant or is not significant. Okay. For example, if you have the correlation between Q and OTR, okay, Q and OTR is negative 0.78, but is that significant? Next time we meet, we are going to check whether each of these correlations are significant. We're also going to see how you can generate a correlation matrix using R, because in everything, R is stronger than the Excel. R will give us more information than Excel will give us. Ladies and gentlemen, that brings us to the end of the entire caboodle.